All right, so yet another rice table word problem example. So you really want to get comfortable with this, right? You really need to know how to do this in order to do well in the class. And so in this case, it tells us that a half-liter vessel contains 0.0125 moles of H2S, gives us the value of Kc, and then tells us to find the concentration of H2 and S2 at equilibrium, and gives us the overall equation. So naturally, we want to start off with our rice table. And so we write out rice, and then we want to write in some initial concentrations. However, this problem gives us a volume and an amount, right? That's not a concentration. A concentration is amount over volume, right? So we can say that the concentration, initial concentration of H2S is going to be equal to 0.0125 moles over 0.500 liters, right? If you didn't do this step, you would end up getting the incorrect answer. And so the actual concentration here is 0.0250 molar, right? That's what we want to plug in here. And we're assuming that the reaction has just started, so we have no products. And so the change here, our reactants are going to go away. So this will be negative. And then don't forget this coefficient here is 2. So this needs to be minus 2x. This coefficient is also 2. And so this is plus 2x. And then this coefficient is 1. So this is just plus x. For the E line, we just add these two up. So 0.250 minus 2x. This is just 2x. And then this is just x right here. Next up, we can write our K. So from our equation, we know that K is equal to the concentration of H2 squared times the concentration of S2 over H2S squared, right? Don't forget these squared parts either, otherwise you're going to end up with the incorrect answer. And so now we can plug all this stuff in, right? We know that the concentration of H2S is equal to this, right? 2x for H2, and then just x for S2. So this ends up with 2x squared times x over 0.250 minus 2x. And then we also know the numerical value for our Kc, right? It's 0.15 or 0.167 times 10 to the negative 7. And then we can use our assumption again, right? Times 10 to the negative 7, that's a very small number. So we can say K is small, which means X is small, which means some number plus or minus X, right? In this case, this 2X is approximately equal to just that number. And so that'll simplify the math for us. So we'll end up here with 2x squared times x over just 0.250. Whoops, I forgot the squared up here, the squared up there. Don't make that mistake, obviously. And this is equal to 1.67 times 10 to the negative 7. So we're going to solve this algebraically. So first thing we're going to do is multiply both sides by 0.250 squared. Is it 0.250 or is it 0.250? 0.250. 0.250. So you got to be careful again. Make sure all your numbers are correct. It's very easy to make a mistake here. 250, there we go. And then we have to think about what this left side is going to be. 2x squared is going to be 4x squared times x. So then this ends up being 4x cubed. And then to solve for this, we're going to divide both sides by 4 and then take the cube root of both sides to get x by itself. And then if you plug and chug that through your calculator, you'll get 2.97 times 10 to the negative 4, and then we have to test our assumption. So our original number is 0.0250. So we're going to take this number and then divide it by that, and then multiply by 100, and it should be within 1%. So let's see, 2.97 times 10 to the negative 4 divided by 0.0250 times 100% will equal 1.19%. And so that's definitely less than 5%. So our assumption is valid here. And then we can continue on with the problem. So it wanted, at the end, what it wanted was the concentration at equilibrium of H2 and S2. So we can use our table to find out that the concentration of H2 is going to be 2x, and then the concentration of S2 is just going to be equal to x, right? So we can then write concentration of H2 at equilibrium is equal to 2x. Concentration of S2 at equilibrium is equal to x. We now have our value of x, so we can go ahead, plug that in. This one will just be the same number, 2.97 times 10 to the negative 4. And then this other one will just be double that. So see, 2.97 times 10 up to the negative 4 times 2, 5.8 not 88 times 10 to the negative 4. And then there's your answer. So again, just get really comfortable with doing these ICE tables. There's a lot of little ways to mess up, and the best way to kind of get better at them is just practice, practice, practice.